Lesson 3, Introduction to Vectors. The reason introduction is actually we're not supposed, vectors aren't part of Physics 11, but when I first started teaching Physics 12, kids struggled with this enough that we decided, Mr. Kamosi and I, that we would do some vectors in Physics 11 to give it a chance to kind of percolate, to let you think about it. You with me? You're not foolish looking at your phone or anything, are you? No, you would never do something that silly, ever. In physics, any quantity is either a scalar or a vector. Everybody got the notes? Yeah, okay. Scalars have magnitude only. They have size, and that's it. Vectors have both magnitude and direction. Magnitude and direction. So, for example, we have displacement is a vector quantity. 6.5 kilometers due west. 8.7 meters north. I'll go get them if they do that again. Distance, 205 centimeters. No direction. Magnitude only. Velocity, 80 kilometers per hour north. Now, look up for a second. I would love to abbreviate north with a capital N, but what other unit uses a capital N? So what I'll usually do to show you that a direction is occurring, I do the @ symbol, like the email or the Twitter, except my @ symbol looks terrible, so I'm just telling you that if you see that weird, that's an @ symbol, north. Speed, 80 kilometers per hour. Acceleration is a vector. Yep. Yep. But you don't know the direction. It only has a magnitude. It's a scalar. If there's no direction attached to it, then we assume it's a scalar value. Okay? It'll become clearer as we go through. It will. Acceleration is a vector, 9.8 meters per second squared down, or what's the other way that we showed down quite frequently? How did we show down? Negative. We're going to get away from that a bit this year. You're going to find this year there's going to be some situations where it just turns out to be way more convenient to let up be negative and down be positive. We'll do that, but yeah. I wrote here 22 seconds. What's the thing that's always a scalar? Time. Time is not a vector. No negative time. But I watched a sci-fi movie once where they went back in time. No, we're gonna stay within our universe. Time is gonna be positive. Momentum. Momentum is a vector. Who remembers the letter that we used for momentum, the symbol? We couldn't use M because M was taken by mass. It was a product, so we used P. We would say something like this. P, and there's our vector symbol, equals 12. Who remembers the units for momentum? It was mass times velocity, so that gives you a hint for the units. Mass was measured in kilograms. Velocity is measured in. It was kilogram meters per second. Now that there, going to Josh, if they just gave me that, I would assume they were only giving me the scalar component of momentum because there's no direction. Oh, they want to make sure that's a vector. Then what they'll do is they'll go at, how about 32 degrees north of west. N of W. There's a direction. And we'll practice that what of what thing a lot over the next few days. Volume is a scalar. You can't say that volume has direction. What do we measure volume in? Begins with the letter L. Liters. Now look up. The abbreviation for liters is a lowercase l. The problem is if I write that, what does that also look like? So I will always, just some conventions that you'll figure out, I will always do that for a lowercase l. Oh, and while we're at it, Dale, That's a plus sign. That's a T. I'll always put the little curly thing on the T. What's that? What's that? A Z. I'll always put a line through it. If you don't see the line, then it's Mr. Dueck's messy 2. I'm trying to be more consistent, but in North America, we typically often do that. Sorry. Force. 19, making up a number, units for force. Newtons. At 12 degrees, you know what, I used a 12 already. Let's pick a different number. 60 degrees west of south. Worker energy was a scalar. It just was. What were the units for worker energy? Do you remember? Joules. 3,000 joules. Is that a lot? We'll talk about that when we get closer. Now, we add scalars like normal math. Mass is a scalar. 8 kilograms and 6 kilograms is 14 kilograms. But to add vectors, we must add them vectorially. How? Well, we're going to, Martina, represent vectors with arrows. And one way that we could do this would be to carefully draw the arrows to scale on graph paper using a ruler and a protractor, and then carefully measure the distance between them to scale, and then unscale. That's a lot of work, and that's a lot. You know what? I would rather use trig, and that's what we're going to do. So our diagrams, Dustin, can be close, but they can be rough diagrams, and the trig will take care of itself. Little note, by the way, in a textbook, vectors are written in bold font. That's really tough to do in your handwriting. It's tough. Okay. There, that's a vector V. We don't do that in our handwriting. Instead, to show a vector, we put an arrow over it, except over the years we've gotten lazy, Alex, and we've stopped putting the bottom part of that arrow. We just put the top part of the arrow, and that arrow clay is meant to signify direction. Oh, and for what it's worth, if I only want the scalar value, the magnitude, that's what absolute value means in physics. Those of you that saw the absolute value thingy last year, and you were, why are we doing that in math? Turns out in physics, what I really care about is just how big it is, but not what direction it is. The positive answer, not the negative answer, because I don't care the direction. Oh, that's what we were doing. Yeah, last year. So, we could draw a scale diagram using a protractor. Or better yet, Thomas, we could use trig. To add two vectors, we are going to draw them tip to tail. Tip to tail. Sean, how am I going to draw two vectors? I got a hankering to add two vectors together. Alex, any suggestions on how I should draw them? Tip to tail. Tip to tail. Travis, if someone said to you, would you mind telling me how I might want to draw two vectors if I wanted to add them together? What might you suggest to them? Draw them how? Tip to tail. Tip to tail, you'd be right. I want to add some vectors together. I'm going to draw them tip to tail. Tip to tail. You're going to have to memorize that part, not on your formula sheet. You will when you're doing the homework, and because I've done this stupid repetition thing. But how do I draw vectors if I want to add them? Tip to tail. And then the resultant, the sum, the answer, is from the tail of the first to the tip of the second. You know what? A picture is worth 1,000 words. Let's gulp. Example 1. Well, example 1 said, oh, I forgot. You know what? Oh, there it is. Example 1. John travels 5 kilometers west and then 8 kilometers north. What's his displacement? First of all, what distance did he travel? 13 kilometers. What's his displacement? What did DALP stand for? So some good habits. Are they mentioning in this example 1 question north, south, east, and west? They are? Then I always draw a compass rose somewhere off in the margin. Also because that way, Kevin, my question's no longer blank. I feel better. Can you read to me example 1, please, Kevin, my friend?
John travels 5 kilometers west.
Stop. 5 kilometers west. I would do this. An arrow pointing this way, west, and I'll label it that. Keep reading.
Then 8 kilometers north.
And then,
What is
that sounds like a plus. 8 kilometers north, I'm going to draw an arrow pointing which way? Or up the page. Now, I'm going to be roughly to scale. Is 8 bigger than 5? Is it twice as big as 5? So my arrow is going to be bigger, but not twice as big. I want to add those 2 vectors together. Alex, in the back row, any suggestions on how I should draw them? Oh, I was going to free. Any suggestions on how I should draw them? Tip to tail. Tip to tail. Here's what that's going to look like. I'm going to draw this. There's the tip of the first vector. That's where I'm going to start the tail of the second vector. The resultant is going to be from the tail of the first to the tip of the second. This, I'll call it D vector, is the displacement. Hey! You know what that means? It means I can find the magnitude. How can I find the magnitude? It's actually something you learned way back in Math 8. How can I find how big D is? Pythagoras, holy smokes. It's going to be 8 squared plus 5 squared equals D squared. Don't forget to square root when you're done. 8 squared plus 5 squared. I'm going to go equals square root button, answer button. Square root of 89, but why would I do that when I can use my answer button? I get, oh, how many sig figs am I always going to go to? 2 or 3? I'll go 9.43. 9.43 what units? Yay, we're done. No, we're not. That's a scalar. That's a magnitude. Now, I need the direction. At. How do I find the direction? I go back to where the vector is coming from. Right here. This is the theta, the angle that I'm going to find. That 8, opposite, adjacent, or hypotenuse. That 5, which trig function? Tan. What always goes next to the trig function? The angle. What's the angle this time? Theta equals opposite over adjacent. How am I going to find an angle? Oh! All calculator, isn't it? This is the invert, shift, arctan, arcsine, arctan in this case. I bet you Mr. Dueck started with 58 degrees and then just reversed the numbers. He did. Is it 58 degrees? Yeah. What of what? North of south, east of west, what of what? Okay, so here's how you draw this. You start out going west, and then what direction do you go of west? This is north of west. North of west. Now that last little bit kids find tricky. We're going to practice this. It's funny though, I always tell the story. I had a basketball player, one of my top kids ever, about 10 years ago, Dylan Gatner. You guys will play him in the grad tournament. Strong academic kid. He could not wrap his brain around the what of what. And so he just memorized all 16 permutations. I saw he had a piece of paper, he drew every one of them out. He asked me to label them. He says, you know what, it's just easier. I can memorize this. So, okay. But I'm going to try and teach you just to be able to figure it out because, you know. Example 2. Because I'm pretty sure looking at this that they want me to add 2 vectors together. Any suggestions on how I might want to draw them? Tip to tail, you don't say. We're going to draw a little picture. What's the first vector? By the way, have you guys turned the page? Then you don't need to redraw a compass rose. If you had turned the page, I probably would suggest it because the number of times I've seen kids botch the directions would amaze you. But here, I'm going to redraw the compass rose because I've scrolled down and I've lost my compass rose. So let me do that. North, east, south, west. What's the first vector? Not 10 north. Read very carefully. And I did this on purpose because it happens. What's it? Read me this whole thing. You heard the little hamster start running on the wheel again up there, right? Squeak, 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 squeak. Okay, ready? What? Sorry, what? By the way, we only got 26 letters in the English alphabet. Some of them are both units and directions because W is also watts. I mean, sorry, just look. S is also seconds. Look very carefully at the context. That's why I'll use that at symbol all the time. So 10 newtons do what? Okay, so that's going to be about that big.
6 newtons do so.
And I want to be roughly to scale. Is the 6 bigger or smaller than the 10? More than half as small or less than half as small? So I'll draw it not quite, a little more than half as big, roughly. The reason I do that is that way when you find an angle, it kind of looks right on the paper. In other words, I would hate it if you solved for an angle that looked like that and got 70 degrees. It should be like that. Well, we can prevent with a little bit of thought. So that plus south would be down. How did you say I should add those vectors together? Now, turns out for adding, it doesn't matter whether you go 10 plus 6 or whether you go 6, don't write this down, plus 10. You're going to get the same answer. Sort of. Sort of. Try this one on your own. I'll do it up here. Let's see if we get the same thing. Thumbs up? Except, Jordan, what if you had drawn the 6 first and then the 10, like I suggested? You would still get 11.7 newtons, But instead of getting 31 degrees south of east, you would end up getting 59 degrees east of south. You would have ended up finding this angle right here, which is just as, it's fine. So you're going to see often in my answer keys, anytime I write down an angle, you'll actually see two angles, the first one and the second one, because I don't know which order you drew them in first. How many of you got that okay? Excellent. Excellent. A little thought. If we add displacement vectors of 2 meters and 3 meters, what's the maximum sum we can get? What's the biggest that I can get if I add 3 meters plus 2 meters vectorially? Five. It just all same direction. What's the smallest I can get? How? It says explain your answer using relevant physics principles. So last time I did an explain question, we made up reasonable numbers and we crunched it. I think this time we can dollop. In fact, I'm going to go like this. Since there's an A and a B, I'm going to say here, and I'm going to say here, Travis, what picture could I draw if I wanted to show that 5 meters is the maximum sum?
Draw 2 arrows, tip to tail, going in the same direction.
And I can even do a bit more than that. How long should that first arrow be labeled?
3 meters and 2 meters.
Spencer, how could I draw yours?
One east and one west.
No, I'd take, that's perfectly fine. I can read from that. I know what you're talking about, sure. You could do more, I guess, and write big flowery paragraphs. I usually say the less English, the better the proof. Everything else is going to be something in between, because if the maximum value is 3 plus 2, 5, as soon as you start angling that vector, this distance is going to get smaller, and the smallest you can get is 1. You can fill every decimal value in between. There you go. Three vectors is not physics 12. It's first year physics, but I'll show it to you because you actually know it without realizing it. So it says this: for the 3 vectors below, draw the sum of 2a plus 5 plus b plus 0.5c. How do you add 3 numbers together? If I say 3 plus 4 plus 5, what is 3 plus 4 plus 5? 3 plus 4 plus 5 is 12. Turns out, though, Jason, there is no way to add 3 numbers all at once. You have to go 3 plus 4, get an answer of, and then add the 5. Okay? Same with vectors. Oh, you want me to draw 2a plus b plus 0.5? I'm going to go 1 vector at a time. I'll add the first 2, get an answer, and then I'll add the third one. Or maybe I can do it all in one fell swoop as a picture. Let's see. What do you think 2a would look like? The same as vector a, but what? Twice as long, and now you just figured out how to multiply a vector by a scalar. Ah, there you go. So I would draw this. B, okay. I'll just redraw it. What would 0.5c look like? Hey, how would I add 3 vectors together? Draw them, tip to tail, followed by draw them, tip to tail. It's going to be tip to tail, tip to tail. It's going to look something like this. That plus that plus yunk that. What's the resultant from the tail of the first vector to the tip of the last vector? I guess, unlike with numbers, actually, Jason, I can add three vectors simultaneously. There it is. This would be, I'll call it vector R for resultant. Now, I'd need numbers before I could do more, and even with numbers, that would be a pain to solve, because numbers, I don't have a way of doing 3 at 1. But vectorial picture, sure. We can even do physics 11 with vectors 12. An object is initially moving at 3 meters per second east. Have we all turned the page? I'm going to put a compass rose on here because I see the word east. Also, that way my question is no longer blank. I feel better. Object is moving initially at 3 meters per second east. It accelerates south at 1.5 meters per second squared for 4 seconds. Find the final velocity by adding v final equals vector v initial plus vector at. Oh. Now this is vf equals vi plus at, which we flogged to death last year. But last year we didn't really emphasize, actually, it works for even yucky vectors. It wants me to add some vectors together. Max, any thoughts on how I might want to draw them?
Tail.
Tip to tail. That's a thought. So maybe a good idea. So I'm going to draw VI. How big is VI? Magnitude. 3. Direction. East. So, you know what, Manny? I'm going to 3. Plus. I'm going to draw AT. What direction is AT? Yep. South. So it's going to go down. Don't do that yet. How big? Well, I'm multiplying them. What is A? How big? What is T? How big? What's the magnitude of A times T? 6. How does that compare to my, what was my original vector here? How big? 3. You know what? I'll draw the 6 exactly how many times as long? Twice, heading which way? About like that. Trav, any thoughts on how I could add those together? Well, that's a great suggestion. 3, 6, and I guess, Travis, V final, and I'll call it V final because that's what it is in my equation, is that their thing with the lovely right angle? Oh! I can use Pythagoras again, holy smokes, and SOHCAHTOA to find, oh, theta is going to be right there. By the way, that angle, see it? North of south, east of west, what of what? South of east. You start out heading east, and you go south of east. Okay, solve that. Find VF, find theta. How many degrees? South of east. I'll do it up here. Let's see if we get the same thing. Square root of 45. 6.71 meters per second at I might be wrong. I did that in a hurry, but you got that too? Okay. I like this question just because it's kind of neat that we took VF equals VI plus AT, which you guys have almost become bored with. And I showed you, you know, they don't have to be going in the same direction. It just ends up being a vector addition equation. Kind of cool. Here we go. Those of you listening at home just jumped through your headphones, but that's also fun. Next page. This is an A+ level question. I like this question, I like this question, I like this question. Why would I say that, Spencer?
Because it would be on the test.
Did you hear me say it was going to be on the test? You're just kind of the student that notices when a teacher tends to emphasize certain things. Except I will say this. This question here, I can already see, because of that right there, this is not going to be SOHCAHTOA. This triangle is going to be sine law, cosine law. I think on your test, I won't make it a sine law, cosine law question. But this is a lovely application of vectors, airplanes, and crosswinds, oh my. So I figured I'll make the homework example tougher, and the test, it's nice if you find the tests easier. Okay? Here's what it says. Read along with me. An airplane has an air velocity, or engine velocity, I'll call it that, of 200 meters per second north. There's a wind blowing 60 meters per second, 35 degrees south of east. What's the plane's ground velocity? What you need to realize is the velocity relative to the ground velocity, is made up of the engines and the wind. What the radar sees is how the plane is pointing and how the wind is blowing. Or, if I wanted to, I could think this as an equation. V engine plus V wind combined with V wind, Nick, gives us V ground. Is that okay, Nick? Question? Okay. Read the question very carefully, Nick, my friend. Oh, you know what? I've turned the page. I'm going to put a compass rose because this is a tough question. Read the question carefully, Nick, my friend. Can you see in the question what the engine velocity is? Magnitude and direction? So, DULP. Now, DULP stands for, who remembers? What I'll often do, since I have the equation there as well, I'll draw each arrow underneath the proper section of the equation. In other words, there's my engine velocity, 200. Plus, can you read to me, Nick, the wind velocity?
60 meters per second.
Keep going.
35 degrees south of east.
Okay, south of what?
East.
South of what? Say it again. I'm doing this for a reason. South of what?
East.
South of what?
East.
South of what? Draw the east first as a dotted line. What of east? Goes south. This is how you draw these. This is why I'm walking you through that. So when it says something of something, south of east, south of what? South of east, south of what? You draw the east part first, and then you go in that direction, south of east. We're talking this angle right here. Oh, and how big is this angle going to be according to the wind speed velocity? That's the magnitude. How big is the angle going to be?
Oh, 35 degrees.
Yeah, I'll fill that in. What's the magnitude of my arrow going to be? Yes. Okay, do you see how that came together? That's how I handle this A+ level question. I'm going to be stubborn, I'm going to be clever, but I'm going to write stuff down and be uber organized. Hey, is there a plus sign between them? Nick, I'd like to add these two vectors together. Any suggestions on how I might want to draw them? Tip to tail, you don't say. Really? So if I hear you correctly, and I think I do, you're saying this. It's going to be 200 plus 65. And I figured 65 is about 1/3 as long as 200, so I drew it about 1/3 as big. Oh, 60. Why 65? Because of the 35. My bad, guys. 60. Which is still about 1/3 as big as 200, so I drew it about 1/3 as big. Whew. The resultant is from the tail of the first vector to the tip of the second. That line in red is what I want. I'm going to zoom in because I've drawn this small and you guys can't see at the back. So there. By the way, SOHCAHTOA, do you see a right angle there anywhere? No. Did they give me an angle in the question? Nick, what was the angle that they gave me for the wind?
35.
Now, look up. It seems to me that's that angle. Is that not right? Looking at the picture? And that's not in my triangle. But if this angle, don't write this down, is 35 degrees, how big is that angle? What do these two add to? 90. Ah, so how big is that guy? You can either do it in your head or on a calculator. I'm going back to Nick. How big is the angle inside the triangle? It is. Now, I'm going to erase this so it doesn't clutter up my diagram, and I'm just going to go like that, but can you see how we were able to just extend the line and figure it out? You're going to find, Dustin, you can extend horizontal and vertical lines, and there's going to be some right angles somewhere, even though you can't use SOHCAHTOA, you can at least find an angle. Sine law? No pair. Cosine law. Or I think it was someone in this class who also said, yeah, it is side, angle, side, and the one across from it, but it's not a pair. So it's going to be the cosine law. I'm going to shrink down again so I can fit this all in a little bit more. What does the cosine law say? It says, what are we trying to find? In my triangle, what am I trying to find? It's meant to be really obvious. It says v squared equals 200 squared plus 60 squared minus 260 cosine 55. Now you'll notice this time I didn't write out the cosine law with variables. I said I've spotted the pattern. What I want goes by itself. The other two numbers, Mr. Dueck said A and B are interchangeable, so as long as they each show up once and then they each show up after the 2, I'm good. Oh, squared, squared. Oh, and then the angle, kids never get the angle. I mean, they clue in. Yeah, the angle goes there because it's a theta. Go to your calculator. Don't forget to square root. (200 squared plus 60 squared minus 2 times 200 times 60 cos 55. What the? Oh! What I better remember to do? Because it's not going 29,800 meters to square root. And I get a magnitude of 173 to 3 sig figs. 173 what? Units, please. Now, if they had just said, oh, I've just realized why I had so little room. I gave you guys a bunch of room down here to write the triangle, didn't I? Because now it says when we draw the vectors tip to tail, okay. I was going, why did I leave so little room? I'm zooming in. Oops, sorry. If this question had said, find the, and this goes back, Josh, to your question. If this question had said, find the plane's ground, don't write this down, speed, we're done. That's its speed. But they didn't say find the ground speed. They said find the ground, which means since it's a vector, I need to find both the magnitude and the Well, look at that red vector in the triangle. The direction is going to be where it's coming from. Theta is going to be that thing. By the way, that angle there, what of what? North of south, east of west, what of what? I'll give you a hint. I think there's going to be an east and a north. It's either east of north or north of east. Which one? Huh?
East of north.
Start out now. Here's how you do it. Again, the vertical or horizontal part is going to be the of. That's why. North of what? North of what? Okay? That's always where you start. So go north, and you're going east of north. So it's going to be east of north. How big? Oh, I can't use SOHCAHTOA. Wait a minute. Don't I now know how big this is? Say yes. Well then, I've got a pair. I can use the sine law to find an angle. What's the sine law? Well, that's going to look like this. It's going to be the sine of 55 over what's across from the 55, which was 172.72. I'm going to use my answer button on my calculator. Equals the sine of the mystery angle over what's across from the mystery angle. What is across from the mystery angle? Ah, Mr. Dueck. What, Dale? I think that's 1 fraction equals 1 fraction. You would be correct, sir. Are you saying I can just kind of move stuff? In fact, really, I think the 60 is going to move to the front of the sine 55. I think what I can actually say, Dale, is yoink, yoink. Yes? Well, that's cool. So I'm going to go 60 sine 55 divided by, answer button, because that is not just 172.72, it's 172.72, blah, 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 blah. What the? Why do I have such a small decimal? Oh, I haven't found theta. I found the sine of theta. What else do I have to remember to do, man? Inverse sine. Answer button. 16.5 degrees. Oh, here's the whole mess then. At 16.5 degrees. What of what? North of south, east of west. What of what? That's a tough question. Welcome to Physics 12. But also understand that's a useful question, because I'm telling you, when airplanes are navigating, they can't always fly at lovely right angles. In fact, really, when airplanes are navigating, it's even tougher because they're going over a curved ground below them. It's far more complicated even than this. You need something called spherical geometry, which has even weirder rules. Now that's using the cosine law and the sine law. And you'll notice I was able to fit it in a fairly small area in terms of numbers of lines of work. If you remove the drawings, 3. There is another way to do this that does not require the sine law or the cosine law. If you're next page, very uncomfortable with the cosine law approach, now my first advice would be it's worth getting comfortable, because it is by far the slickest, shortest, nicest way to do it. Not the easiest, at least writing. You could, Mitchell, if you don't like the cosine law, use components. This involves breaking every single vector up into its vertical and horizontal components. And I wrote here is the above example done via components. I'm not going to do the above example via components. I'm going to try and nudge you into wrapping your brain around the sine law or the cosine law, and I'm going to say this. If you really want me to show you how to do this with components, pop by after school one day and I'll walk you through it individually. But you're also going to notice, instead of 3 lines, about 8. But it's going to be all Pythagoras and SOHCAHTOA, so it's up to you. I like the cosine law because I'm a math nerd. So you get the same answer. I prefer to tip the tail method, but you'll get full marks for either. So, we know how to subtract vectors. Sorry, how to add vectors. How do we subtract vectors? The short answer, Alex, is we don't. Instead, we turn it into an addition question. How can I turn it into an addition question? I add the opposite. If you ask me to go, don't write this down, vector A take away vector B, instead I'll go plus negative. Now, first of all, plus, how would I add the vectors together? Really? Really, people? How would I add the vectors together? How would I do a negative? Flip it. There, by the way, there is a way to subtract vectors. When I said we don't, there is a rule. It's you draw them tail to tail, and the resultant goes from the tip of the longest vector to the tip of the shortest. You know what? Why memorize an entirely new rule when, Clay, with a minimum amount of thinking, I can turn it into addition tip to tail? That's what we're going to do. Okay? So I wrote down here, how do we subtract two vectors? To subtract A minus B, we're going to turn it into A plus negative B, where negative B is the opposite direction of B. Example 3. I like example 3. I like example 3. I like example 3. Example 3 is a nice question. Why would I say that, Kyle? Did you hear me say it was going to be on the test, or you're the kind of student that tends to notice those when a teacher tends to emphasize certain things? Well, good, 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 good. A plane's ground velocity, or velocity relative to the ground, is 240 meters per second due east. I've turned the page. I see a direction. I'm drawing a compass rose. If the wind is blowing at 80 meters per second due south, what's the plane's air velocity? Here's an equation that's worth, if not memorizing, being able to derive. Understand, whenever a plane is moving, the air plus the engines gives you the ground, what the radar sees. Understand, V air, you know what? I don't like that. I'm going to say, instead of air, engine, because air and wind sound too much alike. I should have changed that. Put a little ing there. Engine, engine, engine. The engine. Which way is the plane pointing is really what we're saying. We have this. The engine plus the wind gives you the ground. The engine plus the wind gives you the ground. Thomas, what's this question asking me to find? It says, what is the plane's engine velocity? This one. How could I get this one by itself in the equation? How could I move this over? But when I say subtract, we're going to be subtracting vectors. Okay. In other words, as an equation, I'm going to say this. What they want me to find is going to be the ground velocity take away the wind velocity. You okay with that, Amelia? Except, how do I subtract vectors? I don't. What do I do instead? Add the opposite. How do I subtract vectors? I don't. You know what I do instead? The opposite. Opposite. Can't just add them. Because that's wrong. Adding and subtracting aren't the same thing. But adding a negative is the same as subtracting. In other words, look up, look up, look up. Do this. Dunk, dunk. Because, Thomas, I think that's what you really said. Dulp. Draw a little picture. What is the ground velocity, oh pray tell, magnitude and direction, according to this question? Read. Magnitude and direction. 240 meters per second east. I'll draw that underneath here. That would look kind of like that. Plus. What is the wind velocity, magnitude, and direction? What would the negative wind velocity be then, magnitude and direction? I'll give you a hint. Still 80. Ah. There. Kevin, I turned it into something I already knew. Oh, and also I'm sensing, thank God, SOHCAHTOA, not sine law, cosine law. I want to now add these two vectors together. Thomas, any thoughts on how I could add these two vectors together? You don't say. And I guess the resultant is going to start from the tail of the first guy to the tip of the second guy. Oh, 200, 240. Copied it down wrong. Is that what you're looking at, Kohei? Sorry, my bad. Yay, right angle. Yay, Pythagoras and so. Oh, man. None of this cosine law, sine law, minusing 90, filling in angles. This should be okay. You know what? I'm going to call this, how about V-eng, since that's what I'm trying to find. So, it'll be 80 squared plus 240 squared equals V-eng squared. $80 squared plus 240 squared equals square. It's going to work out evenly? No. Okay. 253 meters per second? At I guess theta is going to be that angle there, where it's coming from, always where the vector is originating from. North of south, east of west, what of what? Clay? What was that? You're right. So I'm just going to leave a space right now already and go n of e, and I'll just fill in the degrees there. Start out going east. Sorry, that way is east. I got to reverse everything in my head all the time. East for you guys, and then north of east. How big? We can use SOHCAHTOA. That 80, opposite, adjacent, or hypotenuse? Opposite. That 240. Mr. Dueck. What, Clay? Mr. Dueck, I've noticed that whenever we've done SOHCAHTOA, this one was tangent. This one was tangent. This one was tangent. This one was tangent. Mr. Dueck, will it always be tangent? No, but usually. Usually. Oh, too far. Okay. Tan theta equals opposite over 18.4 degrees. Is that yes? 18.4 degrees north of east. Raj, how do I add two vectors together? Tip to tail. I think that's right. Dustin, how do I add two vectors together? That sounds like a great suggestion. Dale, knock knock. How do I add two vectors together? There you go. Travis, a man walks into a bar and he says, how do I add two vectors together? What would the bartender say? Probably would. Okay. There's a bunch. I just want to make sure you remember it. I love Foxtrot comics. The creator, Bill Ammond, actually has a degree in physics. In fact, while he was in university, he would doodle a lot on the side and show them to his friends. And this is funny. You should try and publish this. And I also love it because the young little boy, the nerd boy, Jason, I may occasionally tend to identify with. So here's Jason's older brother, Peter. The two of them are playing football. And Peter says, Jason, what pattern did I tell you to run? You said go 10 yards out, then 10 yards to the right. And what pattern did you run? I went 10 root 2 yards at a 45-degree angle. And are they the same thing? Well, if you had the vectors, sure. This is football, not math class. Why do you think I rounded to 2 decimal places? And then there's this one. Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. And Peter thinks, hey, won't I be right back where I started? Well, I can't throw very far. Okay, here's a new play. I never get to be quarterback. I have run that. One time we had a nice sunny day at this time of the year. We took the kids out on the field. We have run this play. The physics is correct. You do end up with a vector sum of 0. It is. So he does the physics correct. I love that. What's your homework? A couple of things.